Okay, we are asked to evaluate the sum. That's 6 plus 12 plus 24 plus dot 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 to 48. Okay, looking at this question, this is a question on geometric progression. Yes, because from the values of the numbers, you see that the common ratio of this, because is a GP, the common ratio is 12 over 6 or maybe 24 over 12, which is 2. Yeah, so this is a geometric progression or exponential sequence whose first term T1 first term, this is first term, T1 is first term 6, common ratio 2, and the last term, nth term, is 48. So we're asked to find the sum, but if you could remember, the sum of the first n term of a GP is always equal to T1 Rn, that's r raised to power n minus 1 over r minus 1. So we normally use this if r is greater than 1, but the other way around, 1 minus r raised to power n 1 minus r when r is less than 1. But in this case, r is greater than 1. But we have a little problem here. We don't know numbers here, the total numbers here that we are to find the sum. So we need to use another formula. So if you could remember, the last term of a GP is always T1 r raised to power n minus 1, where this is the last term or nth term. So, and again, if we try to get n, making n the subject of formula, it will make the solution hard. So there's a way I will solve it so that it will be easy. So we've noted that T sub n is T1 times r raised to power n. So we can write this as T1 r raised to power n over r because of the 1, power of 1. So we are subtracting. So once we see subtraction, means division. So making, as you can see, you now see that Tnr is now equal to T1 r raised to power n. So this makes our solution very easy, because if we open up the bracket, this is T1 r raised to power n minus T1 over r minus 1. And we can replace T1 times r raised to power n as Tnr. So making it very easy for us to solve. Because if we try to get here, if we try to solve for n, we'll move to logarithm. Yes, so we don't need it. So the best way is to express it in this form. So we can now say that we have three formulas for sum of the first n term of a GP. So we have this if r is greater than 1, but we have the other way around, that's T1 1 minus r raised to power n divided by 1 minus r. So we use this if r is less than 1. So, and this now we use this if we are given the first term, the last term, and the common ratio. So we don't need the number of terms. You see it. So we now see that the sum is now equal to Tn is 48, r is 2, that's times 2, minus T1, which is 6, over, as you can see, our common ratio is 2. So 2 minus 1. So as you can see, this is 960 minus 6 over 1. 2 minus 1 is 1. So we have 954. So that's the best way we can solve this. That's option A. That's the fastest way to solve, because if we try to solve for n, we'll move to logarithm, and we know some of us are not conversant with logarithm, so, and it will involve calculator. So this is the best method. So we use this form if the first term and the last term are given. So thank you.